I welcome everybody to this screencast of overview of Azure Cosmos DB. My name is Rafat Sarosh and I'm a program manager in Cosmos DB team. So before we talk about Cosmos DB, let's find out what are the problem this database is trying to solve. So let's see what are the challenges faced by modern apps today. So number one is managing and syncing data distributed around the globe. So the world is truly flat and your app is no more constrained to a region. So your app is distributed, your users are distributed, and the data is distributed around the globe for these apps. Second is delivering very highly responsive and real-time personalization. So personalization is no more a premium feature. It's a min bar. All the app must know you. And on top of that, it has to be very highly responsive because anything less than 500 millisecond is considered too slow. So today, if all the web pages you go to, if it's more than 100, 150 millisecond, most probably you are going to leave that page. And number third is processing and analyzing large amount of data and a complex data. Because we are trying to do the personalization, I have to have all the history, all the preference of your user, and I have to process all this at almost at the real time. And because my applications are global in nature, so it's very difficult for me to predict upfront that how much throughput I may need or how much storage I may need. Depending on the success of your app, your throughput and storage requirements just go through the sky. So we need something where we can scale both throughput and storage based on a global demand. It should be auto scale feature should be there. And offering low latency to global user, as I said, low latency is the must have thing. There's no compromise on that. Anything a couple of 100 milliseconds, it's too slow and you are in a risk of losing the customer. And all these modern existing apps, they have to have this personalization, recommendation, social integration, and gamification. And all this need massive amount of data and which has to be processed almost at the real time. And in Microsoft, we were seeing these challenges for our own apps like Xbox, Skype, AD, MSN, and we have to solve this problem for our own apps. And this brings us to Azure Cosmos DB. This is a fully managed, multi-model, multi-master, globally distributed database service for low latency and high throughput demand of modern apps. So Azure Cosmos DB, this is a database born in cloud. So the fundamental design goal since the inception was to have automated global distribution, limitless scale, low latency, high throughput, and well-defined 5 consistency model and comprehensive SLA. So we build the platform with these core capabilities, and top of this we build multi-model database. And as you can see, in this database, you can keep different kind of data. You can keep key value, column family, documents, or graph. Because in any enterprise, you will never have all your data kept in one form. Your data is generally in different formats. So that's why Cosmos DB is called multi-model database. So you can have different kind of data stored in just one database. You don't have to have separate databases for separate kind of data. So if you see our competition, you need a graph database separately, then you need a document database separately, and then for column family, you need another database. So that's the beauty of Cosmos DB. In this database, you can keep all this different kind of data in one database. And now, how to interact with this data. So we didn't want our users to learn something new when they are coming to Cosmos DB from different platforms. So if you are a Cassandra user or a MongoDB user or a Graph Gremlin user, you don't have to learn anything new. You can keep using those tools and those applications which you are familiar with, you just move your data from Mongo to Cosmos DB and still keep using your same application by just changing a connection string. You change the connection string Mongo to Cosmos DB and everything should be working as is, because we are fully compliant on the wire protocol of Mongo and Cassandra and Gremlin. So here, for Cassandra, Mongo, and Graph users, you don't have to learn anything new. But for SQL, we have our own client library. And this library is in C#, in Java, JavaScript, and in Python. And every day we are adding more and more languages to this client library. Now let's dig deep into each and every feature of Cosmos DB. So let's talk about global distribution. So Cosmos DB is a ring 0 service of Azure. So wherever Azure is, Cosmos DB will be there. And today, Azure is in 52 data centers. And Azure have more data centers than the Amazon and Google combined. And once you distribute this data, you get 5 nines of availability. This brings us to manual and automatic failover. So if your write region is in one region and suddenly that region goes away, the system will automatically flip over to the next region and your users will not feel any hiccups. Your application will keep working. The users may just realize that your system for the first call become little slow for a few hundred milliseconds because you flip from one data center to another data center. Remember, this is not the delay for every other read. This is just the first time when the data center was flipped. This is what we call with automatic failover. And manual failover, some of our customers use the follow the sun model. When it's a day in Australia, they will have a write region in Australia. When it's a day in Europe, they will move the write region to Europe for the high throughput and low latencies. So this will change a little bit because now we're going to have, which we already announced, that we are having a multi-write region, but that will go GA very soon by next September. So today you have one write region only, and for that you can do this manual failover to move your write region from one place to another place. And all your data is automatically synchronized behind the scene. You don't have to do anything. And when you want to distribute this data, what you have to do, you go to this web page, and on the map you just click on these different data centers, and here, as you can see, you will have a list where all you are distributing your data, and you can change the priority, that if my write region, which is West US, it goes away, I should flip to West Europe or Australia Southeast. You can change these things on the portal. So this is as simple as that. And if you have come from SQL Server or other databases, you will realize that how beautiful and how simple it is to distribute your data globally. Now, next is elastic scale out of storage and throughput. So the system automatically scales out as your need. So there are two things. One is the storage and one is the throughput. So the storage will keep increasing as you will keep using the system. You don't have to do anything. It will elastically scale out. You don't have to even do any configuration. When you were creating the collection, you will say, I want unlimited collection, and that's it. Nothing needed from your side. And for the throughput, as we provision all the resources when you ask and when you create the collection and give us your number for the throughput. So, but if you want to change the throughput, so you can change the throughput on the portal, or you can use a 2-line of code to change this throughput. So really, throughput and storage, it elastically scale out. We have one of our customer for the Black Friday, they went to 3 million request units per second, and once the rush is gone, they come down to their normal working load. So the storage and throughput both elastically scale out automatically for you. Here's another thing I will just bring it to your attention, that we have this option that you can set this time to live TTL for some number of seconds or minutes. And the beauty of this, that after a while the data will be deleted and you don't have to pay for that deletion like our other competitors, where you have to pay even when you want to delete the data. And here the data will be automatically deleted and you will get back that storage. And we have a guaranteed low latency. So all our reads come back within 10 milliseconds and write in within 15 milliseconds. That's for 99 percentile. But if you'll go a little below, most of our customers get this read happen within 3 to 5 milliseconds. And then we have a 5 very well-defined consistency models. And this is one of the differentiating factor between Cosmos DB and other products in the market. Because if you see all this NoSQL non-relational databases, they generally give you two kind of consistency, strong or eventual. And you have to choose between this two end of the spectrum. Or there are some other databases like Cassandra who will have like 11 consistency model, and you have to be very savvy computer science guy to figure it out what and how to set up those consistency models. And it requires a lot from you to understand inner working of databases. But here in Cosmos DB, we abstracted away all this from you, and there's just 5 radio buttons were given. So you can choose these consistency model. And not only you can choose to start with, but later on while you are developing your application, for every call you can change this consistency model if you need to. So let's start from the strong consistency model. Strong consistency means once you get the ACK back from your write, you are guaranteed that your data is written. Once you got the acknowledgement back in the strong consistency, it means your data is written. No matter what will happen, you will never lose that data. So that's what the strong means. And the next is bounded staleness. So what happened in strong, that you write and then you wait for acknowledgement. So there's a cost you are paying for 50 milliseconds or 100 milliseconds for data to come back, because you said it's strong. Cost means you are adding the time waiting for the acknowledgement come back to you. So this is what the second consistency model addresses, that issues, that where you want the strong consistency but you don't want to wait. So you can say, I want a bounded staleness consistency model. By that you mean that I am okay, I can tolerate that data is stale for 5 minutes, but then it is written. Or I can be fine that if my data is behind by X number of writes. So when you want multi-region consistency but don't want to pay the price for the waiting of the ACK coming back, that's the time you will use bounded staleness. Next one is session. Session is very simple, that you read, you write. So that's the session consistency. And then the consistent prefix. Consistent prefix says that you will get the data on the other end in the same sequence in which the data is written. By that I mean is, if somebody has written A, B, and C and D, you will get on the other end in the same sequence A, B, C, D. You will not get like D before A. And this will be used, this kind of consistency model, if you have a chat application where you will never see the answer of a question before the question. So that's where you want to use the consistent prefix. And then eventual is a eventual consistency. But if everything is normal, there's no breakage of the cable or anything like that, then eventual consistency also is as fast as with the speed of light. This consistency happens. So we have this 5 very well-defined consistency model, and you appreciate this more as you go in your development cycle, and then you realize, oh, I am fine, or I need a consistent prefix for this kind of load, and then you can move you can change the consistency model per call basis. Now we already talked about that we have multiple data models and different kind of APIs on top of this. As I said, you can keep the key value and column family. So the Cassandra is in preview. We will be going GA by September. And of course, MongoDB is there, and Mongo APIs, and a lot of our users are already using Mongo. There's a pretty big chunk of customers who moved from Mongo to Cosmos DB because of all the other benefits you get of Cosmos DB, like high throughput, low latency, geo distribution, and 5 very well defined consistency model. So we are seeing a large number of Mongo customers moving to Cosmos DB. And then we have Gremlin for graph databases. And then we have a very comprehensive SLA around latency, like our reads are less than 10 milliseconds for 99 percentile, high availability 5 nines, throughput is guaranteed, consistency is guaranteed, and all this is financially backed by Microsoft. And you will see all these numbers about latency and throughput and consistency and high availability. All this is shown to you on your Cosmos DB portal. Cosmos DB, being the Ring 0 service of Azure, gets all the benefits of Azure. And Azure is the most trusted cloud with more certification than any other cloud provider. It provides you enterprise grade security, encryption at rest, your data, index, backups, attachment, everything is encrypted. And encryption is enabled automatically by default. You don't have to do anything. So data is at rest is encrypted, data in motion is encrypted, and there's no impact on performance, throughput, or availability. It's completely transparent to your application. We have a very comprehensive Azure compliance, and Cosmos DB have plethora of certification. We have a long list of certifications. We have ISO 27000, SOC 1, SOC 2, FedRAMP, IRS, High Trust, and we just got FedRAMP High also certification for Cosmos DB. Okay, before we go any further, let's take a look at the resource model of Cosmos DB. So on the top level, we have an account. So tenant of the Cosmos DB service starts by provisioning a database account. So once you have an account, underneath you can create databases, containers, and items. So this is the hierarchy model of hierarchy of all the resource model of Cosmos DB. And all these resources can be accessed by a URI. Now we have a URI for an account, and then we will have two kind of keys, master key and a read-only key, to access this account and all the resources inside this account. So this is how you will go and create an account. If you are on an Azure portal, click on this plus sign and follow the arrow, and then you will go and choose a database, and then choose Cosmos DB, and then you start entering all this couple of fields, which is asking you what is the ID, what's the name of your account, and then what API you want to use. These APIs can be SQL, Cassandra, Mongo, Graph, or Table. So one of the APIs you choose, and then you choose your subscription and resource group, choose the location, and that's it. And you click create, and your Cosmos DB will be created. And once your account is created, beneath that you can create database, and then you can have multiple containers and items. Now here's something to understand. There's a line below between account and database. So anything happening at account level, we call it control plane operations, and below that account level from database onwards, we call data plane operations. So for the control plane operation, we do have AD authentication. AD integration with Cosmos DB. So you can come to the portal and create your account and manage it. Below that, once you created an account for Cosmos DB, you get the read and master key, and using that you access the Cosmos DB. But there is another model where you can define a very fine granular permission on database, on containers, or even at an item level by using the resource token model. That's a separate subject, but there's a lot of documentation on that you can go and check, and then you can see how you can do a granular permission on Cosmos DB. Here's how you will create the collection below the database. Here you just simply give the collection name and you choose what the storage capacity you want, and generally if you choose unlimited, then it will continue grow as your need will be there. You don't have to worry ever about your storage. And here you are putting the initial throughput capacity. You can put whatever you want, but you can change this later on also. So if you started with 1000 RU per second, later on you realize, oh, I need 5000 or 10,000, you can change that too. And then you just define your partition key. We'll go in more depth about the partition key. That's it. And then you click OK and your collection is created. Now, beneath the collection or at the document level, we have three more things, which is stored procedure, triggers, and UDF, user defined function. And all those three things you define or write in JavaScript. And these stored procedures are a little different than the stored procedure what you know of in SQL Server, because once you have this stored procedure or trigger and UDF, they are called by your application. They are not triggered because something happened to the document. So these are little different than SQL. And then there's another thing called conflicts. So in a container, you can get some conflict documents. And so how these conflict documents come about? So if you remember, when we are doing the global distribution, our data is distributed globally and we have an automatic failover also. So suppose, imagine that you have US West and US East, and West was the right region, and then suddenly some failover happened and the system automatically flips to US East and chooses that as a right region, and US West is down. But US West went down before it can replicate some documents to East. So the document is written to West and it went down. It didn't have time to replicate the document. Now when the US West will come back and it will see there's a conflict happening because there was some documents which were not replicated to other region, those documents will go in the conflict feed, and there's a separate function there where you can say I want to read all the conflicts, and then you can resolve the conflicts depending on whatever your business rule is. So it's again very well documented, but just go ahead and check the documentation. Now this is the resource hierarchy. You have tenant on top, they have account, and beneath that you have database and collections, and these collections can be of different type. And as you can see, these resources are your data is kept in 4 different places. We call it a replica set. So when you write the data, it's written to a leader, and then it copies this to 3 different places, which are 2 are follower and 1 is the forwarder, to move that data to the remote resource partition if you have geo distribution enabled. So as you can see, your data by default is written to like 4 places. So that's why we guarantee you 5 nines availability, like your data can never be lost. So after this, now quickly let's look at partitioning, because that's one of the most important subject, and often people get confused in this topic. So you must be wondering how Cosmos DB provide you this low latency of 5 minutes 5 milliseconds or 10 milliseconds to read and write. And the magic is in partitioning. The way you partition your data, that's how the way you partition your data helps Cosmos DB to achieve this high throughput and latency. So what happens when you are writing a data to Cosmos DB, you define a partition key. And this partition key has to be something which is very, very granular. The more values you have, the better it is. So if you have a partition key which is user ID, if you have millions of users, that's good. You don't have to worry. So this partition key is not equivalent to a physical partition. By that I mean they are connected logically, but it does not mean that if you have millions of partition key, you will have millions of physical partition, because hundreds and thousands of partition keys can sit on one physical partition. So one is a logical concept and another is a physical concept. So this is often a source of a lot of confusion from a lot of people. They wonder that, oh, if I'll have this partition key which have millions of values, will I'll have millions of partitions? No. So what we do is we take the partition key and then we hash it, and take the value of hash and then divide that hash between your physical partitions. And again, here, as we are showing in this diagram, that there may be 5 partitions, but you don't have to worry about number of partitions you have. What you have to worry about is when you are provisioning a collection, you only focus on how much RU you need. So that's you define. You say, I want 10,000 RUs per second, which is a request unit per second. And that's all you have to worry about. So and systems take care of everything, how the partition key will go to the partition and everything else. So here's an example. I have this n number of partitions. As I said, you never worry about how many partitions you have, because for storage you only pay what you use, and depending on how much RU you have provisioned, the partitions are made for you by the system. Okay, so now you are inserting the data which will hashed, and using the hash the data will be distributed among all these partitions. And the trick here is to have a partition key which will have many different values, very granular. The partition key with high cardinality is better. The more different values you have, the better it is. Okay, now as you can see in this diagram, I am putting this data in this partition, and then what will happen when this partition get full? So one of the partition is getting full, so what will happen? So system will, behind the scene, it will split that partition into 2 partitions. So one partition went into partition x plus 1 and x2. So this partition is split. It all happens behind the scene. You don't have to worry. You don't have to do any configuration or anything, nothing. You just keep inserting your data and system will take care of this in splitting the partition. And the key here is these partitions, you can see it on your portal, and you have to make sure that your partition fill like this, that all your partitions are filled in equal amount. Like there shouldn't be one partition is filled too much and one partition is not filled enough, because that is the sign of having a bad partition key. So when you have a good partition key, all your partition, the physical partition, will look like this. They should look same. If that is the case, then you are good. Your design is good. You will have a good throughput. You will have a good latency. But if your partitions look like this, like one of the partition have all the data and other partitions are almost empty, that's a sign that you made a mistake in choosing the right partition. So this is the key thing. And I will tell you, like 99% of projects get into trouble because of this one problem, that they don't define a proper partition key. So the trick here is to have a partition key which can distribute your data among all these partitions very nicely. So let me talk about change feed. So change feed is a persistent log of records in Cosmos DB. So whatever the data is getting inserted in Cosmos DB, you can listen on the change feed and you can get all that records. So that's what is change feed. Change feed is kind of a window by which you can see inside Cosmos DB and see what records are getting inserted, what are getting updated. So today in change feed you get the insert and update records. Delete is coming soon, but you can put a soft delete to get those records come in the change feed and then have a TTL so those records get deleted. So in short, this change feed gives you a log of records what is inside the Cosmos DB. And now you can have Azure functions written which can listen on the change feed, and this helps you enable write your microservice architecture on Cosmos DB, because you can have these multiple Azure functions are listening to one change feed as the records are coming in. These functions can be triggered and then they can do any business action on it. So change feed is a very, very powerful feature of Cosmos DB. It helps us enable patterns like event sourcing. You don't need to have another event source like Kafka or anything else to enable your event sourcing or do your microservice architecture. All the data can go in Cosmos DB, and listening on change feed you can do a couple of things. So one is having this Azure functions, enabling your microservice architecture, have it to Azure Notification Hub, so you can send notification depending on whatever is happening in Cosmos DB, whatever kind of data is coming. And there's a separate screencast on change feed for an hour, so I'll not cover it in depth, but there's a lot of options, functionality, patterns can be enabled using change feed. One pattern we see a lot of people use, that they can use Spark or Azure Stream Analytics to work on the change feed. As the data is coming in, they can do the machine learning using Spark here. They can use this change feed to move the data to a different data store, to move the data to the cold storage. As I said, there's a separate screencast just on change feed and Spark integration, and there's many patterns can be enabled because of the change feed. So I'm just introducing you guys with the change feed, but to dig deep into it, you can go and search on the web, just search Cosmos DB and change feed, and you will get an in-depth overview of change feed. So now let's go back and look at why a user will choose Cosmos DB. What are the reasons that you will choose Cosmos DB over other products in the market? So here are the top 10 reasons why customer will use Azure Cosmos DB. So the number one is it's the only database which has a global distribution turnkey capability. As you already seen, to distribute this data, you have to just go and click couple of mouse clicks on your portal and your data is distributed. The simplicity of it, you will be in awe of it. You will be in love with this feature, that to distribute this data globally, you have to just go ahead and just click couple of mouse clicks. And it delivers massive storage and throughput scalability. As I said, we have a customer who went to couple of million RUs per second, and then they come down when their load is gone. So this kind of elastic scalability is not possible, and it provides guaranteed single digit millisecond latency for 99 percentile, all the reads happening in 10 milliseconds, write in 15 milliseconds. And it natively supports different type of data at massive scale. As we already seen that your data don't have to be only in JSON, it can be a graph or it can be a white column. So all this multi-model data is supported by Cosmos DB. And we have this 5 very well-defined consistency model to pick the right consistency for your solution. You don't have to be choosing between two extreme end of the spectrum like strong or eventual. So you have lot other options here in Cosmos DB. And all this is on top of this multi-model data. So all this different kind of data which you are storing supports all this different kind of consistency model. It enables the mission critical intelligent applications because of its nature of auto scaling in throughput and storage, gives high flexibility to optimize for speed and cost. As I said, you can change the RU requirement when you need more RU to process your load, and when you don't need, you can scale it down. So you can optimize for speed or for cost. It tackles big data workload with high availability and reliability. Like as I said, you can have terabytes and petabytes of data, and whatever load you will throw at it, it will be easily able to handle. We have customer already who are in terabytes and terabytes of data. And it does provide the enterprise grade security. As I said, we have a long list of certifications which we have for Cosmos DB. So no matter from which country and which vertical, from which industry you come for, we will have a certification for you. And it's naturally analytics ready and perfect for event driven architecture, because Cosmos DB have this feature called change feed. Using that, you can build event-driven architectures on top of it. And we have a native integration with Spark. So you can take this data from Cosmos DB to Spark, and then you can process the data there, and then you can write back the data from Spark back to the Cosmos DB. And here are the list of our customers who are using Cosmos DB, and as we can see, our growth is almost 35% year over year, and 20% of our customers migrated from MongoDB to Cosmos DB. And we are very proud of this fact that we won the Technology of the Year award for 2018. With this, I will take a pause and answer any of your questions.